All right, we're back and we are on a new set of notes. I believe this is note 9 of math analysis. We're on page 91, I think. And we're starting what I call 14 formulas. So 14 formulas, definitely one of my favorite things. I say 14 formulas a lot because every time they come up, I'm just like, ooh, 14 formulas. So these are going to be formulas that relate to the trig function. So we're going to start with one that's out of this world crazy. It's going to show up all over math going forward for you. It is called Euler's Formula. And Euler's Formula is insane. It says e to the I. Remember, I is actually the square root of -1. Like, that's what I is. E to the I times theta, the imaginary unit times theta, what is happening there, is equal to cosine of theta for some reason, plus I times sine of theta. Isn't that nuts? It's amazing. We're going to use it in so many applications. We don't really know enough math yet for this to make total sense. However, if you go back, way back, maybe like notes 2 or 3, we had something that said that cosine of x was the sum from, I'm going to say like, let's go, n equals 0 to infinity of -1 to the n x to the 2n over the quantity 2n factorial. We also had something that said sine of x was, and we like looked at these, but not super closely because again, the math is beyond us, but not so far beyond us. 2n plus 1 factorial. So we had these formulas. If you play around with these formulas, I think you will find out that something is true. But you would need to know one other thing. E to the x is also equal to. So these are crazy. They're called Maclaurin series, and they will be a big part of your life at some point. But if you play around with these specifically, here's what you do. Right, so it's all based on this. 1, sub in x equals I times theta. 2, write a lot of terms. So just write, I don't know, like 7 terms, write a lot of terms. Okay, the next thing you're gonna do, regroup. So you only have things that don't have an I together, and then you have things that have an I together, and you can factor the I out of everything that has an I, right? And you'll get like an infinite number of terms plus I times an infinite number of terms. And then compare to sine and cosine. And then if you do that, you will see that making a lot of assumptions, e to the I times theta is equal to cosine theta plus I sine theta, which also I made a video of that if you just want to watch me do it. So seek that out. It's probably in the playlist for these notes, probably, which is different from the playlist of the notes. There's a playlist to support the notes, and then another one that just is the notes. So you got to make sure that you're looking at the right playlist. But in the playlist to support the notes should be that, I think. Let's see if we can use it. So here's a thing. So we know that e to the I theta is going to be cosine theta plus I sine theta. All right, so e to the, I'm going to say pi times I, e to the pi I is cosine of pi plus I sine. Ooh, I forgot the I. Let me move this over. I times sine of pi. So what's the cosine of pi? So the cosine of pi is -1. The sine of pi is 0. So really what we have here is that e to the pi I equals -1. Are you kidding me? E raised to the pi times I. The imaginary number, pi, the irrational number, e, the irrational number, combine them in this way, you just get -1, which is it's insane. And then also, this one is just kind of renowned for its beauty, I guess. These are the 5 most important numbers in math, all in the same thing. E to the pi I plus 1 equals 0. You got 1, you got 0, you got I, you got e, you got pi, you got everything. So Euler's formula connects a lot of stuff. So here we go. We're going to use it to do some stuff. So for some reason, we're going to find e to the I quantity a plus b, which should just be cosine of a plus b plus sine of I times sine of a plus b, right? Just replace every theta with a plus b. Well, if we do that, focus on the left-hand side. E to the I a plus b is the same as e to the IA plus IB, which is e to the IA times e to the IB, right? That's just properties of exponents. But e to the IA is going to be cosine of A plus I times sine of A. So this now is going to be cosine A. I'm not going to use parentheses because it gets way out of control, but they should be there. So this is the same as e to the I times A. And then this cosine of B plus I sine of B is the same as this. So far we haven't really done anything. We just used some properties of exponents, and then we kind of like expanded some stuff, or substituted. Now we're going to expand. So by expand, I mean multiply it out, and it's going to be not great. So we're going to get cosine A cosine B plus I cosine A sine B plus I sine A cosine B, and then plus I squared, which we're going to have to do something about, and then sine A sine B. Sine A sine B. Okay, so that's just from expansion. Now, the only like real simplification that I would do is I would note that I squared is actually -1. So we have cosine A cosine B plus I cosine A sine B. So I don't really know why this is the rule other than like convenience. When you have multiple trig functions, you tend to alphabetize them by their variable. So that's why like cosine A is going first, and then sine of A is going first. I don't know. It's, you know, you got to have conventions like that, otherwise you lose your mind trying to read things, which I think is really why this happened. All right, so now we're going to rearrange this into, I'm going to take the things that don't have I and put them first, kind of like I suggested doing if you wanted to work out Euler's formula from those series. Minus sine A sine B. And then plus, I can actually factor an I out here, so I'm going to I. And then I'm going to rearrange this so it looks like the famous thing that you'll end up memorizing. That's the only reason I'm doing it. So sine A cosine B plus cosine A sine B. Okay, so now if you recall, which maybe you do, all of what we just wrote is actually equal to this. Let me use a different color. Nope, same color. Hold on. Color's not my thing. This is the part we haven't touched yet. All of that is equal to everything that we've written. Like every step is true. These are equal to each other. And since they're equal, I'm just going to write equals cosine of A plus B plus I times sine of A plus B. So if that's the case, then this is one of those properties of complex numbers that you may or may not remember, where you would have A plus BI equals C plus DI if and only if, which is IFF, A equals C and B equals D. That's the only way that those can be true. So since that's true, that must mean that the cosine of A plus B, which is the thing that doesn't have an I in the bottom part, must be equal to cosine A cosine B minus sine A sine B. What? And then also the parts with I should be equal. So the sine of A plus B should equal sine A cosine B plus cosine A sine B. So these are going to be 2 of the 14 formulas. What color should I highlight them in? I'm going to highlight one of them in this. Actually, I'm going to highlight both of them in this. So we have, these are called the sum formulas. Why are they called the sum? Because it's A plus B, you're adding them together. These are, you got to memorize these right now. You're already up to 3 formulas. You got E to the I theta equals cosine theta plus I sine theta. If cosine of A plus B is cosine cosine, so this is how you usually say it, cosine cosine minus sine sine. Because it's multiplication, it doesn't matter what the order is, so you can just say cosine cosine minus sine sine. Sine of A plus B kind of matters, so you do sine A cosine B plus cosine A sine B. So with cosine, you're like not going with the same symbol, right? We have plus here and minus here, whereas with sine, it follows the symbol. So sine of A plus B is going to have a plus in the formula. Cosine of A plus B is going to have a minus in the formula. These are that's the start of memorizing these. So there's 14 of them, and you know 3, and that's pretty good. So we're gonna get there. So let's see how it works, just because we're here. So let's say cosine of pi over 6 plus 2 pi over 3 should be equal to, according to this formula, cosine pi over 6 cosine 2 pi over 3 minus, because it's cosine, so it's the opposite, sine sine. Okay, but then we got to actually like work this out. Well, cosine is 1/2. That's wrong. Sorry, whoops. Cosine is radical 3 over 2, and then the cosine of 2 pi over 3 is negative 1/2, minus the sine is 1/2. The sine of 2 pi over 3 is positive radical 3 over 2. So if you look at this, we're getting negative root 3 over 4 minus root 3 over 4 is negative root 3 over 2. But what did we really just find? We found the cosine of 5 pi over 6, which we already know is negative root 3 over 2. The formula works. I'm trying to prove to you, like, we just derived the formula, but that's not really a proof. Like, nobody really believes that. Also, in the videos to support the notes, there's a different proof of these formulas, if you would rather see that. I love this proof, even though I know it's built like on kind of a shaky foundation, because you have to believe in those series, but those series are real. So this will be sine, cosine. What are you? You're supposed to be over 3. And then plus cosine, sine. Auto shapes killing me. All right, so now we just got to figure this out. So what we're really finding is the sine of 5 pi over 6. So we know that the answer is going to be 1/2. But why? You got 1/2. You get negative 1/2 plus cosine is radical 3 over 2. And then the sine is negative radical 3 over 2. So we get negative 1/4 minus, whoops, minus, what are we doing? Negative 1/4 minus 3/4 is negative 4/4, which is negative 1, which does not work. What am I doing wrong? Cosine, cosine, sine, and then the cosine of 2 pi over 3 is negative 1/2. Sine, cos, oh my God, the cosine, what am I doing? Cosine and sine. Sorry, everyone, I've gotten myself confused. Allow me to highlight some things. So the sine of pi over 6, definitely that. The cosine of 2 pi over 3 is definitely negative 1/2. The cosine of pi over 6 is definitely radical 3 over 2. The sine of 2 pi over 3 is positive. Oh my God. Positive. What is wrong with me? Plus, which gives me 2/4, which gives me 1/2, which means I don't need to remake the whole video. That's what happens when a video goes long. Video goes long, you'll lose your mind. All right, so the formulas are working. It's really interesting, I think. But anyway, this is how we can derive them. We're up to 3 out of 14 formulas. I'll be back in the next video. We're gonna do more of them, and I hope to see you there. So let's keep doing this.